Okay, okay. Thank you.
Okay, so started. Okay, see now. I will go back. Over here, see. If you see this compound, this is known as acetic acid. Okay. If you see this compound, this has non-metal in it, metalloid in it, and metal in it. That means this is mixture of all the things together. So this type of compounds, they are considered as weak acids. Now, did you understood like how will you differentiate between strong and weak? So if this type of compound comes to you, it cannot be completely differentiated or completely cut off into two parts. Okay, it cannot go into positive and negative ions completely. So these type of compounds are weak. Okay. Now, coming to the bases. Remember, whenever hydroxide ions, OH minus ions are present in any compound, they are bases. Okay, remember this thing. Whenever OH minus ions are present in any compound, that are considered as bases. Now, if you see, I'm writing NaOH. What is it? What is it? It is sodium hydroxide. Okay, this is sodium and this is OH mean hydroxide. This I will write over here. Hydroxide. Okay, this is hydroxide. So if this completely goes into, okay, this is what hydroxide is, what polyatomic ions or separately oxygen or hydrogen. Am I saying oxygen or hydrogen, or I am saying hydroxide? Remember, hydroxide is a polyatomic ions. It is polyatomic ions. Okay, what does polyatomic ions mean? What does polyatomic ions mean? Anyone can tell me what is polyatomic ions?
I'm not sure, but does it mean
Yeah.
contain
More than, oh yeah, more than two atoms, more than one atoms, and they have any charge which are covalently bonded to each other and having a charge on it. That are polyatomic ions. Over here, if you see, oxygen and hydrogen, they are bonded to each other, they are connected to each other, and both of them, they have one charge. One charge they are sharing, both have similar one charge, which will be written on the top, that will be minus charge. So when any compound come in this state, that is polyatomic ions. Okay, so over here, if you see OH minus in any compound, that will be a base, and that means now this compound should be separated into two parts. That means positive and negative OH should be separated from each other. Okay, or ionized from each other. So if we write this again, it will give you Na separately with positive ions and OH separately with negative ions. So this one will be considered as your strong base. Remember it. This one will be considered as your strong base. Till here, any confusion? I think so, no. So, okay, so I will go to PowerPoint because these were the points which were to be written. And what happened, Yumna? Okay, these points, this also, whatever I am writing, I will share that also with you on Edmodo. Okay, see over here. So see, if you see this thing, see, completely dissociated or completely split up or completely ionized. Okay, that will be your strong acid. Partially or not completely split up, that will be your weak acid. Same is KCC. I wrote over here, I wrote two examples, HCl and H2SO4. They ionize completely in water to give you what? Hydrogen positive ions. Okay. Now, properties of an acid. They are corrosive, their taste is very sour, and they turn litmus paper to red color. Blue litmus paper to red color. Okay. Bases. See. Okay. Now in bases, we have two types of bases. One is metal oxide. One is metal hydroxide. Okay. About what I was talking about. Was I talking about hydroxide or oxide? Anyone can unmute yourself and tell me. When I was talking about ionization, did I wrote hydroxide or oxide? What did I wrote?
I think hydroxide.
Hydroxide. Why did I wrote hydroxide? Because remember the over here. Yeah. Remember one thing. These one, the metal oxide or metal hydroxide, they are, yes, they are considered as bases, but metal oxide, they do not dissolve in water. Okay, they do not dissolve in water. Remember this. Metal oxide, yes, they are bases, but they do not dissolve in water. You can write this point also. They do not dissolve in water. Metal oxide, they are bases, but they do not dissolve in water. On the other hand, metal hydroxide. Okay, on the other hand, metal hydroxide, they dissolve in water and they completely ionized to give you hydrogen positive ions. Remember this. See over here, strong acid. NaOH is written, sodium hydroxide, potassium hydroxide. What will happen? They will ionize in water and they will give you Na plus OH minus ions. Same thing which I was telling you, that if metal is on the first place, negative ions are on the second place, and they completely split up. They completely ionize. That will be considered as strong thing. So over here, for us, this one is strong and the name is changed. Can you see the name? The name on the top now, instead of base, is written alkalis or alkalis. So remember, we will change the name from bases to alkalis when we are using hydroxide. Okay, we will not use the name of base with metal hydroxide. We will use the name of alkalis because they dissolve in water. On the second place, if you see weak alkalis, NH4OH is written. Same thing which I told you before also, mixed. We have, what is nitrogen? What is nitrogen? Metal, non-metal? Anyone can tell me what is nitrogen? Non-metal. Okay, fine, non-metal. So now see, non-metal came on the first place. Okay, non-metal, then metal, then polyatomic ions, mixed up of all the things. So now if this case, this compound this will be considered as weak alkali. Why? Because when you want to split it up, when it goes dissolve in water, it do not give completely ionization of hydroxide ion. OH will be split up, but along with this, NH4 will remain as it is. That means hydrogen is not still removed. It do not went with OH completely. So this will be considered as weak alkali. Okay, till here clear, everyone? Now see, alkalis, they are metal hydroxide, dissolve in water to give OH negative ions, that is hydroxide ions. Okay. Now, for alkalis, remember their properties are they have soapy touch. Soaps which we use, they are slippery or slimy, you can say, and they turn litmus paper blue. Okay. Now, acids and bases in solution. Till here, any confusion? Anything you want to ask, so I will proceed like till here. Anything like differentiate between acid, bases, and alkalis. What is it? How we will differentiate? How we will come to know what are they? Anything is not clear, you can ask me. Any of you? Who is missing today? Okay, is it clear for everyone? Okay, this will become tough for you. I will come back to this. First, I will go on this and then I will come back on this. Okay, let us finish with this one. Okay, now, how we will come to know which compound are acidic, which compound are basic. First thing is that if litmus paper turns red, that is an acid. If litmus paper turns blue, that is your alkali. To check it out, we have two things. We have indicator to check either the compound is acidic or alkali, and along with this, we use litmus solution. Okay, we have indicator and we have litmus solution. Both are used to check out either the compound or the solution given to you is acidic or basic. So remember, for acidic, the color should be red. For alkali, the color should be blue. Okay. Along with this, we are using one more thing that is not mentioned over here, that is pH meter. So you can write it down, that is pH meter. What do that pH meter do? It gives you the values, the number like 2, 3, 4, 5. It comes in this way. Okay. Yes. See over here, if you can see this thing, there, this is pH scale, and this is showing you some numbers from 0 till 14. Okay, everyone, can you see this? This is pH scale. The colors are shown and the numbers are written. Okay. So now, remember, if you go behind 7, that means from 0 till 6, it will be your acidic. These will be your acidic compounds. Remember, these will be your acidic solutions. From 0 till 6 is an acid. Onward from 8 till 14 will be your base. Okay, so this thing you have to write in pH scale. Below 7 will be your acid solution. Above 7 will be your basic solutions. Now, In these two also, the same two things are there, weak acids and yes.
But
Yes.
doesn't it show that 7 and 8 are neutral? So from 9 till 14.
Yeah, mostly probably what we say 7 because near to 8 weak base is there. So normally we consider 7 as neutral and after that weak bases come. Okay? So that's why it is considered as neutral because it is very weak base. Okay? So mostly we say 7 is neutral and above that is the basic compounds. Okay? So now below 7 if you go, so remember from 0 till 3 you can say, or from 0 till 3.9 you can say they are very strong acid. Okay, remember the range from 0 till 3 are very strong acid. Onward from 3.5, from 3.9 you can say, or from 4 you can say, from 4 till 6.9 is your weak acid. Okay, strong acid is from 0 till 3 or 3.9 and from 4 till 6.9 is your weak acid. Now 7 is neutral. How is it neutral? In next slide I will tell you, but 7 is neutral. That means it is not acidic, it is not basic. Anyone can give me any example for neutral, like if you know in our daily life we are using something which is neutral. Any example? Any compound, any solution which you know is neutral? Yes, any example? Water, yes, water. Why water? Why water? Yes, good, Nathalie, water. But why water? You said water, why? Cooking oil, okay. Why is it so? Water, normally we say water. Why is it so? pH is 7, okay. But what is the, like, why is the pH 7? What is the reason behind it? Okay, it does not react. Why? What is the formula of water? Like, what is the formula of water which we use? What is the formula of water? What do we write for water? H2O. Okay. If we split up, and can we write it as HOH? Can it be written as HOH? Normally, if you see on some places, it is written as HOH. Yes, so it is having concentration of positive ions also and hydroxide ions also. That is why, yes, that is why it is equal. Positive ion, hydrogen positive ion is also present and hydroxide negative ions are also present. That is why it is considered as neutral. Okay, so now we are moving on to bases. So remember, if you move above 7 from you can say from 7 till 10, from 7.1 you can say, from 7.1 till 10, they will be considered as your weak bases or weak alkalis. Okay, from 7.1 till 10 they are considered as weak alkalis, and from 10 onward till 14 will be your strong alkalis. Okay, now if you see the colors, what can you observe over here? What are the color observation for you? If you see the color behind, the colors are shown. What are the color observation for you? We will start with acid first. What is the color observation for acidic solutions? Okay, they are red, but can you see, like I told you, na, strong acid and weak acids. So for strong acid, what is your dark colors? Yes. For if you see for strong acids, dark colors are coming. If you keep on moving, yeah, if you keep on moving forward, what happened on this side, over here on this side? The color is getting lighter. Okay, so remember, anything which is strong, either it is an acid or a base, it will show you a darker color. Okay, it will show you a dark color. Dark color will appear. So see over here on this side, if you see, what did I told you? From 0 till 3, this is a strong acid. So see, the color is darker. But if you move on from 3 till 6, the color is getting lighter. So this is strong, this is weaker. Same over here. If you move from 7 onward, from 8 till 10, the color is lighter. So this will be your weak thing, weak base. And if you move, yeah, if you move on forward from 10 till 14, the color is getting darker. So this will be considered as your strong base. This is also the thing which you can say, like if you don't know the pH, exact pH of the solutions. So this is also the thing. If you check on any solution and it is showing you darker color, that dark red color, that will be your strong acid. Light pink or pink the color will appear, that will be your weak acids. Yes, from 10 onward till 14 will be your strong base or alkali. Okay. So remember this thing also, that color darker is strong, color weaker is weak, or lighter color is weaker. Okay, till here clear everyone? Any confusion till here? So should we move on? Okay. So now we will move on to this thing. Okay. What is acid rain? Anyone of you can tell me, like, what is acid rain? And why do we say it as an acid rain? What does acid rain mean?
Because I don't know how many.
Anyone of, yes, yes, Noora. Who will answer me for this?
I think polluted emissions from factories that are taken into the sky.
Okay.
And so like that comes back down in the process of rain being made. I don't know.
Okay. Yeah, okay. And what are they like? What is the range like for acid rain? If I'm saying acid rain, that means strong acid should be present. Acid rain, like acid quantity should be more in that water. In that rain, the quantity of acid should be more. And if the quantity of acid is more, that means it will affect our environment. And how is it affecting our environment? It is harmful. You can say it can pollutant your legs. Water is pollutant. Damage, lot of damage. Our skin can get corrosive. It can harm our skin. Trees, lost of, like we will lose trees. Many things are there. So acid rain basically is the water which contain more quantity of acid. The water which come in the rain form, that is not neutral, the acid quantity is more in it. Okay, till here is it clear? Now, if you want to cut down the acidity of water, can anyone, like, okay, if water is acidic, can soil be acidic? If water is acidic, can soil be acidic too? Anyone can answer. two of them they are missing today. Who is not there? Okay. So can the soil be acidic also? Anyone can answer me. Like if yeah, okay, if the soil is acidic also. So how will you make that acidic soil neutral to make it work for you? Okay, the plant grows slowly in acid rain. Maybe the plant do not grow. It can also happen like in acid rain, the plant do not grow or damage take place. What about soil? Like if we have acidic soil, how will you make that soil useful for the plants to grow? How we will do that? Okay, I will tell you the page from your note from your textbook also. This chapter, acid, bases, and salt. This is on. This is starting from 303 on your textbook if you want to see. And this chapter ends at 312. So in your textbook also, I was asking that okay, fine, we have acid rain. So can the soil be acidic also? So one answer came yes. So if the soil is acidic, how can you make that soil useful for the plants to grow? This is my question. Like if the soil is acidic, fine, but we want to grow the plants. How will you do it? In acidic soil, we want to grow the plant. How we will do it? By cutting down acids. Yeah, by cutting. Okay, by adding an alkaline solution to the soil. Very good. So that means what will happen if we will add in an acid solution? If we will add alkaline solution. What will happen? This thing will happen. Neutralization. That means the quantity of an acid. Yes, the quantity of an acid will go down. It will become less acidic, and the soil from acidic will move toward neutralization. Okay, neutralize. Yes, very good. So whenever with an acid you add any alkaline, that will give you what? Salt and water, which is known as neutralization. Okay, so that means to cut down any acidic solution, we have to add on alkaline solution in it to make it neutralized, or neutralization process is done in this way. And what happened in neutralization? See, one acid is used, one alkaline solution is used, and salt and water is formed. Okay, salt with water formation. So remember, whenever more acidic solution is there, to cut down it, what we do, we add alkaline solution to cancel it out, and we will get neutralized compound or neutralized solution. Okay, and remember, whenever neutralization is taking place, salt will be formed. Water is there and salt will be formed. Okay. So this is neutralization, like cancelling out neutralization. If you will go through it, like how do I see over here? Sodium hydroxide reacting with nitric acid. This is what? This is alkaline. This is an acid. They react together. They give you, see, completely over here, they have shown you that this NaOH will split up into Na and OH, positive and negative ions. This nitric acid goes into hydrogen positive and nitrate positive, and O3 minus. Now, what will happen? This hydrogen positive will react with hydroxide negative, and it will give you what? Water. Okay, it will give you what? Water. Water is formed. And what is left now over here? We have sodium and A, and we have nitrate and O3. This positive will go with this negative, and will form a salt which is known as sodium nitrate, NaNO3, water with a salt. Okay, is it clear till here? I will quickly wind it up because I just want to show you one formula. We will go on this and then I will show you that formula because time just 5 to 10 minutes are left. Okay, so now if you want to prepare, and if we have a salt, if we have like for neutralization we have salt, like salt are formed, fine. Now to separate that salt, if the salt is not soluble in water, if it is soluble or we have a salt, if salt is soluble in water, we have to separate it by a different method, and if it is soluble in water, we have to separate it in a different method. So basically, if a salt is formed in neutralization and it is not soluble in water, we do filtration. Okay, the filtration method is used for it. Okay, if the salt formed is not soluble in water, then we do filtration. Okay, in filtration, what happened? Filter paper is there. On the filter paper, if you put on the solution, water will go down, that is your filtrate. Salt will remain on the top, that will be considered as your residue. You can say remain, you can also say is that residue or remainings. Okay, now another case, like if salt is soluble in water, if salt is there and it is soluble in water, then what do we have? We have to react acid with metal, with alkali, or with metal hydroxide, or with metal carbonates. This I think so, and along with that, if yes, and one more method, like if it is not insoluble, with this reacting, we have titration process also. So two methods we do. Yes, if salt is soluble, we do titration, or we do the reaction of an acid with metals, with alkali, with oxides, or with carbonates. Okay, till here, any confusion, anything you want to ask? This we will go on for the next class because this is in detail. We have to do chemical equations for these. So this will be, we will be doing along with identification of ions. So this we will continue in for the next class. So anything you want to ask me, you can ask me. Because I just want to show you one more thing and then the lesson will be over. Till here, any confusion you want to ask me? Okay, so I will just show you that thing and then we'll get. See over here, I wrote these things. So I just want to show you. Yeah, you were telling me that I got the answer from you that to cut down acidity of a soil or of water, we add alkali in it. So remember, to cut down acidity, we use alkali in it, but the alkali which to make alkali solution, we use quicklime. The formulas for all I will write over here, and yes, you have to learn it. See, we use, and quicklime is present in limestone. First of all, formula for limestone is CaCO3. Okay, CaCO3. Then you heat it up. Heat it up. Limestone is heated. Calcium carbonate. The name is calcium carbonate. If you want, I will write over here also. It will make you easy. I will just post this also. Calcium carbonate. Okay, the name is calcium carbonate. Calcium calcium carbonate, when heated, it goes into quicklime and carbon dioxide. Quicklime is calcium oxide, and carbon dioxide, all of you know it is CO2, carbon dioxide. Okay. Limestone heated goes into quicklime, that is calcium oxide and carbon dioxide. Now, this quicklime, this is used to give an alkaline solution to cut down the acidity of a soil. This will react with calcium oxide, it react with water. It react with water and it gives you an alkaline solution which is known as slag lime or calcium hydroxide. Basically, this is the thing which we use to cut down acidity in the soil. Okay, this is a specific alkaline, this is the specific solution, alkaline solution, which we use to cut down acidity of a soil. And if you want, I will write the name over here. This is calcium hydroxide. Okay, this is the thing, this is used to cut down acidity in the soil. Okay, till here clear? This thing also I will post it, and along with this one worksheet is there. And last week also I got just 5 worksheets, and do complete the last one also and this one also. I will stop sharing. Okay, so I will move on this. Which this one equation? Yeah, equation is confusing, but you have to learn it up. Okay. Anything you want to ask? Anything which is not clear? It is on page number in your books also. It is on page number 305. If you will open your books, it is on page number 305. Okay. I will stop recording also. Okay, and if you want to ask me anything till here, you can ask me. The rest we will continue for the next lesson, how titration